So this is what we were doing last time.
Oh, yeah.
So 0.925 is your first answer. That you simply do.
Yeah.
Correct? NCD and get your answer as 0.925.
Yeah.
Okay. The probability that a student takes between K and 21.8 minutes is 0.3. So that's, as you correctly marked it, this is 0.3.
Yeah.
Find the value of K. So what is this value of K?
Yeah.
Now there are several ways of approaching this thing. Between K and 21.8, this is 0.3.
Yeah, between K and 21.
Correct. This is 0.3. Now you cannot use this area as right because your calculator works with a boundary and extreme.
Boundary and extreme.
Extreme. So either it works with the upper boundary and the lower extreme, or it works with the upper boundary and the left extreme, right extreme.
So it doesn't take it between two things. It takes it
doesn't take
like
that.
infinity.
Negative
infinity and lower to
positive infinity.
So it's like not like a definitive.
So there's no definitive boundary that you can
you
find.
You have to take the other one.
Then you take the other one. You find this area.
Because anything less than 25 point.
Yeah.
And so you put this area 0.9.
And you you add this, no?
What? Add what?
See, you had this.
Yeah.
Correct?
Yeah.
You have 21.8. 21.8 is here.
Yeah.
This area you got as how much?
0.925.
Correct?
Yeah.
Now you have some K over here.
Yeah.
And this area is 0.3.
Yeah.
Correct? So what you can do is, if you want to find the value of K, from 0.925, you can subtract 0.3, means you'll get the remaining area. You'll get this blue area then.
Yeah.
And then you use the left and use 0.625 with the left area.
Wait, so you took 0.925 minus 0.3, so you took it left.
Obviously.
How is that going to help us?
Why? Inverse normal. You take the inverse normal of this. That will give the value of K.
Always look at it, so K will be upper boundary.
Yeah, so inverse K is the upper boundary for the left area. Inverse normal of 0.625 will give you the value of K.
Okay, so let me try that. So 0.62.
So what you've been given in this case, in N2B, so 0.894, that's correct.
Yeah.
Now here, this is an independent question. What you're doing in this is, you are having a bell-shaped curve, correct?
Yeah.
Then you're having that x is greater than a. So there's some a, look, there's some a, and probably that x is greater than a, this probability is 0.27. Find the value of a.
So you just have
inverse normal, right?
Yeah, so they've already given, so
inverse normal, right? So get inverse normal and get this value. So get 462. That was a different sum. It was a different sum. It was between two values. It's a different sum. Every sum you don't have to do what you did in the first sum. Now you've been given the volume of drinks in a can is normally distributed with mean as 333. So you have normal distribution, correct? The mean is given to be 333. So mu is equal to 333. Okay? Correct? Fine. 20% of the cans, given that 20% of the cans contain more than 340 ml.
Probability of X on the graph.
Correct? So this is 340 ml.
Yeah. And then
correct?
Yeah.
And this area, this probability is 0.2. 20% is 0.2.
Yeah.
Correct? Find a standard deviation. You have to find now the standard deviation. Now what you can do in this case is, now whenever you start to enter this value in inverse normal, so go to inverse normal. Correct? Which area will you take?
You would take
right or left?
Right.
Correct?
It's going to
so put right.
And then you put
What's the area?
Area is 0.2.
0.2. Now do you know the standard deviation and the corresponding mean?
You know the mean, we don't know the standard deviation.
But if you see, it's like a couple. If people are married, you can't call only the husband or the wife. You have to call the couple together.
Yeah.
Mr. and Mrs. Khanna, please come. Like that. So that means if I'm putting 333 as the mean, I should call 3 ka wife. Do you know the 3
Who is
3?
333's wife?
We don't know that.
We define
So
that.
what we need to do is, then you have to put what we call the standardized value, which is the Z value, for which you put your mean as 0 and standard deviation as 1.
Oh, always.
Always. So these are your standardized value.
Okay.
Enter. And that will give you your what we call the Z score. So if you put, whenever you put mu as 0 and standard deviation as 1, we'll count a Z score. And what's the Z score coming to?
0.842.
No.
Yeah.
Who said that? In middle of a sum, don't round off.
Oh.
Take 5 significant figures.
41621.
Yeah. Take, you can take more also if you want, but at least take 5. At least take 5. Now what you do is, now you use the formula Z is equal to X minus mu upon sigma.
Is this in the formula booklet?
Yeah, is there in the formula booklet? Z is equal to X minus mu upon sigma. What is the value of Z we got?
This is 0.8416. 2123.
What is X?
What's it? It's 0. No, oh, now you know to use this.
X is 340. X is 340.
Sorry.
What is mu?
Mu is 333. Yeah.
Standard deviation. And that will give you the value of the standard deviation. Work it out.
Okay. So X is like the value that's at the lower upper limit or whatever.
Yeah, the limit value is your X value.
X.
Are you following that?
Right.
So you have, so whenever you don't know mu and standard deviation, when you use the standard value, you'll get the Z score.
Yeah.
First get the Z score using 0 and 1, and then you apply this formula to get the.
Mean is 0, standard deviation is 1. Okay.
So 8.32 is the standard deviation. So important, huh? Important sum.
So now I'm going to ask a question, please.
So what you did, the first part you did correctly. In the first part, what you did is, yeah, you first you find a standard deviation. You use 168.
Yeah.
You did the inverse normal,
Yeah.
correct? And then you got that. This is stuck over here.
Is that bad?
For some reason it's not going there. It's going this way, but it doesn't refuse to go there. Anyway, you got the value
Oh,
of Z.
yeah, you can just get rid of the sidebar. But still not going.
Still not going there. This thing here.
What do you use that?
So what you can do, see, you got this area as 0.17, that down area,
Yeah.
and you want this 166. You use that. Yeah. 0.17 and 166.
Yeah.
Correct? 168 I mean. You
Yeah.
use that and you get your first, you use your inverse normal of 0.17. This is not well written, 0.17. You did that. You got the
Yeah.
Z value.
As
0, you got the Z value.
0.9541.
Yeah. And then your second step you use Z is equal to X minus B upon sigma.
Yeah.
And you got the value of Z.
Standard deviation.
Standard deviation you got. I mean. Now this standard deviation don't run off because it's an intermediate value.
Yeah.
Now we know that between 192 and 192 minus h, this area is 0.8. Now I've just drawn a diagram like this. It can be like yours, it can be like mine.
Right,
We don't know where it
so it
is.
doesn't matter whether it's right.
We don't.
or whatever.
But I'm saying why it will be on the other side because 0.8 is way more than 0.5.
Yeah, that's true. Yeah.
So that is half the thing is 0.5. So it's beyond that. So what you need to do now is, listen. What will we do is, we'll get this area. Can you get this area?
Yeah. I'll do that now.
Correct? Can you get that area?
Yeah, possibly.
And once you get that area, then you can get things off.
Okay, because you just said do the 1 minus this.
And then you work it out. Yes.